All right, so in this lesson, we are going to take everything we've just learned about equations and inequalities, and we're going to use them to model real-world scenarios and find solutions within the context of the problem. So by the end of this lesson, you should be able to answer these 5 questions given a specific scenario and come up with the answers and then apply that. All right, so I want you to just start with these 2 questions. Chris wants to order DVDs online. Each DVD costs $15.99, and the shipping, the entire order costs $9.99. If he can spend no more than $100, how many DVDs could he buy? And then 331 students went on a field trip. 6 buses were filled, and 7 students traveled in cars. How many students were in each bus? So just go ahead and take a minute and just think about that in the context of the real world and see if you could come up with either an answer or some sort of equation or a guess at the answers to both questions. So some of the things that I noticed in the first problem is that he has $100 total to spend. And no matter how many DVDs he buys, he has to pay $9.99 in shipping. So I'm going to go ahead and take that 100 minus the $9.99, and that leaves me with $90.01. So that's how much money he has to spend on DVDs that cost $15.99 each. So if I were to divide that by $15.99, I get 5.6. Well, if I think about what it's representing, how many DVDs, I can't buy 0.6 of a DVD. If I round up to 6, I'm going to spend more than that $90.01 that I have after shipping. So I'm going to say 5 DVDs. At most, he can buy 5 DVDs. So in the second one, I know that we have 331 total students. I know there were 6 buses, and I know that 7 students traveled in a car. So of the 331 students, when I take off the 7 that traveled in a car, that leaves me with 324. So the 324 divided among 6 buses gives me 54 students per bus. All right, so those are just some word problems to kind of get you going. But what happens when it's not so easy and straightforward? So we're going to look at some more tricky problems. All right, so we have been dealing a lot with equations and inequalities. So I want you to just pause the video and see if you can come up with a list of words that indicate it would be an equation. So that it'd be something that I would write equal to something else, versus an inequality where I might say this value is greater than some number, or less than, or greater than or equal to, or less than or equal to. So think about what words or phrases, if I were reading a word problem, that would tell me this is an equation versus this is one situation where I need to write an inequality sign. So what words would indicate greater than? What about less than, greater than or equal to, less than or equal to? All right, so in math, just a couple things we need to know really quickly. A variable is going to represent an unknown value. So if we don't know the value of something, then we're going to use a variable. Usually we use x. And the variable comes from the question because it's the unknown, and when they're asking me a question, that means that's the unknown information. All right, so these are the guiding questions that are going to help me walk through this process of writing an equation and then using that equation to represent a scenario and solve problems about it. So the first question is, what is the question asking? So I always want to go straight to the question. Then I'm going to ask myself, how will I represent that symbolically? So that's where I'm going to define my variable. The third question is, what information do I know? So what information is already given? What's the important information in the problem? How will I represent that information symbolically? And then what equation or inequality will represent the scenario? So these are the kind of thinking process that I go through when I read a word problem and I have to write an equation or an inequality. All right, so the first thing I'm going to do is I'm going to read through, and I always want to start with what is the question asking. So when I go to this, it's asking what is the length and the width of the triangle. So I'm going to write that in on the left-hand side. At the same time, I'm going to ask myself, what information do I know? So I know that the perimeter is 210 units, and I know the length is 30 less than twice the width. So I'm going to go ahead and write that over on the left-hand side. All right, so then I need to make the connection to how I'm going to represent those things symbolically. So the first thing I need to do is I'm going to go to my question about the length and the width, but I have to use what I know. So I know that the length is 30 less than twice the width. So in order to get the length, I have to know the width. So I'm going to call that x. So now that I know that the width is x, I can show 30 less than twice x as that. So that would represent 30 less than twice x. So now I need to think about how can I represent what I know symbolically. So I know that perimeter is 2 times the length plus 2 times the width. That's going to give me perimeter. So when I think about this information, I can say that 210, because I know that's the perimeter, is 2 times the length plus 2 times the width. Well, I know that this is the length, and I know that that's the width. So what equation can I write? So I've taken what do I see, what I can infer, and now I'm going to put it all together, and the equation is 210 equals 2 times 2x minus 30 plus 2x. So my last question is, what is my solution? So I'm going to solve this out. So I'm going to distribute, and I get that. Combine my like terms, and I'm going to add 60. And then divide both sides by 6. And I end up with x equals 45. So the question is, what is my solution in context? So I go back to my question, and it asks for the length and the width. Well, I know that the width is x, so I can say that the width of the rectangle is 45 units. Now, to find the length, I've got to find 30 less than twice the width. So essentially, I'm going to go back and say twice the width minus 30. And so when I do twice the width minus 30, I get 60. So the length is 60 units. Alright, so when I think through these problems, the first thing I always want to do is go to my question. And I'm going to use that to define my variables. My variables always represent what I'm looking for. And then I'm going to look at what do I know in the problem, and I'm going to use that to show symbolically. I'm going to write an equation and solve it, and then my answer is always in context. So it's not just 45 and 60, it's the width is 45 and the length is 60. Alright, so this one, you accidentally went over on your data on your phone and have to pay your parents back $79. Right now, you only have $18. Your uncle said he would pay you $7 an hour to help him do some yard work. How many hours do you need to work to earn at least enough to pay back your parents? So what I'd like you to do is pause the video, and I'd like you to answer these first two questions. What is the question asking, and what information do I know? So go ahead and identify what the question's asking and what you know. Alright, so hopefully you were able to pick out that the question is asking how many hours you have to work, and that you owe $79, you have 18, you earn $7 per hour, and there's one big word in there, at least. So we can earn more than enough to pay back our parents, but we need to earn at least. So now we're going to go over here and we're going to try to represent these things symbolically. So go ahead and pause the video and see what you can come up with. Alright, so when I look at these, I thought about earning plus having. So what I earn and what I have has to be at least $79. I know that if I earn $7 per hour, if X is the number of hours, I can show that by 7X. And I know that at least means greater than or equal to. So what I earn and have needs to be greater than or equal to 79. So when I put that all together, the equation or inequality is 7X plus 18 is greater than or equal to 79. So then I can simply solve it. Alright, so when I think about this is 8.7 hours. So I am not going to get paid for 0.7 hours. So in order for what I earn and have to be greater than or equal to 79, if I said 8, it's not going to be quite 79. So I need to round up to 9 hours because I can't work 0.7 of an hour and get paid. So what is my solution in context? You have to work at least 9 hours to pay them back. Alright, so on this one, the question says the sum of two consecutive integers is 217, and the question is, what are the two integers? So we always go to our question. That's going to tell us what we're looking for. So what is the question asking? We want to know what is the first integer and what is the second integer. Alright, and what do I know? So I know that the sum, and I know that their two consecutive integers is 217. So consecutive means next to each other. So one right after the other. And the sum means I'm adding. So two consecutive integers would be like 16 and 17. And so the sum of those two consecutive integers is 217. So I'm looking for what two numbers, when I put them together, give me 217. So what we're going to do is we're going to define the first integer as x. So if I think about 15 and 16. So we only need one variable because we can't say x and y because then we can't solve for either of them. We can only have one variable to solve at a time. So another way that I can think of the next consecutive integer is if I took x, and so the next integer is going to be that value plus 1. So if I think about 15 plus 1 gives me 16. So this is going to represent the first integer, and this is going to represent the second integer. And then I also know that the total is 217. So I know that the first number plus the second consecutive integer is going to equal 217. So if I plug in my values, this is the first, plus this is the second, and that's going to equal 217. So now I just have a simple problem to solve. So I'm going to combine my like terms. So 2x plus 1 equals 217. And when I get x by itself, I get x equals 108. So if x is 108, the first integer, then that means x plus 1, the second integer, is going to be 109. So my solutions are the two consecutive integers are 108 and 109. And I can check those by saying 108 plus 109 is 216, and they are consecutive. All right, and our last word problem that we're going to work through together is this one. Your mom is deciding between 2 gym memberships at the YMCA. Package A offers a flat fee of $35 and then $2 per class. Package B only has you pay $8 per class, so there isn't a flat fee. So the question is asking, how many classes would your mom have to attend to justify choosing package A? So in package A, I'm paying a lot more up front, but then I'm not paying as much per class. So eventually there's going to be a point, if I go to a lot of classes, where paying a flat fee and then a price per class is going to be cheaper than just an $8 per class. So we need to start with, what is the question asking? So the question is asking the number of classes. All right, so I'm going to represent the number of classes by X. And I know that A offers $35 plus $2 per class. And then B is $8 per class. So if I know that X is the number of classes, then I can write this as 35 plus 2X. And this would represent how much I would pay as 8X. So I want you to understand what we're looking at here. So if X is the number of classes and Y is the cost, then when I take 0 classes in this one, 35 plus 2 times 0 is just 35. And then it's going to go up $2 every class that I take. And so on and so forth. Okay? So in this case, same thing, classes and cost. And in this case, if I take 0 classes, I pay nothing. If I take 1 class, I pay $8. If I take 2 classes, I pay $16. And so on and so forth. So if you notice, this one, if I'm taking a few classes, is going to cost less. However, if I take a lot of classes, this one is going to end up costing less because eventually I'm going to get out. And this one is going up by 8 each time, whereas this one has a rate of 2. So the question is asking, how many classes would your mom have to attend to justify choosing package A? So I need to find at what point are they going to cost the same. And so any amount of classes over that one is going to be, this one's going to be the better cost. So if I'm thinking about when they are the same, that means they're equal. So the equation I'm going to write is 35 plus 2x. I want to know when that equals 8x. Now I could continue my tables out and find that, but we're just going to use the algebra. So I'm going to subtract 2x. So 35 equals 6x. So x equals 5.8. And what does that mean in context is 5.8 classes. So remember we said that this one is the better deal if I take a lot of classes, and this one is the better deal if I take a little bit of classes. So I'm looking for when package A. So I'm looking for if I take a lot of classes. So I can't take 0.8 of a class. So I'm going to have to round up on this one to 6. So at 6 classes or more, package A will be the better deal. All right, so we have done a big chunk of our objective. We've identified keywords, we've defined the variable, we've written an equation or inequality, and we have used our model to find a solution to the scenario. So I want you to have an interaction in your notes. So this is where I want you to step back. What questions do you have, which I'm sure there's some. What makes sense to you? So what are things that you need to remember? What helped you? What confused you? All of those things. This is where you have that interaction that you can bring to class tomorrow and we'll talk about. All right, the second part of our objective is to be able to explain what the different pieces mean in terms of the context. So we're going to look at what does x represent, what does f of x represent, what does the 35 and what does the 2 represent based off of this previous example. So we're basically taking each piece of the equation and we're defining it. So the easiest thing is to always start with what x and what f of x represents. So x is going to be the number of classes. We already said that. So x is the number of classes. And then f of x, which is the output, depending on how many classes I take, my cost is going to be dependent on the number of classes. So now what we have to do is we have to define the 35 and the 2. So in this case, $35 is a flat fee. So $35 is what I pay no matter how many classes I take. So it's that membership cost. And specifically, it's what I pay regardless of number of classes. Okay? And then what does the 2 represent? So I pay $2 per class, so that's my cost per class. So input is what is changing. Output is what is the result of that change. What is my flat fee and what does that mean? So it's dependent, it is not dependent on how many classes. And then 2 is my rate, that cost per class. So I'd like you to go ahead. The perimeter of a rectangle is 100, the length is 40. An equation represents the perimeter. An equation to represent the perimeter can be written as this. Go ahead and pause the video, and I'd like you to try to define as many of those pieces as you can. What do they mean in the context of the problem? All right, so hopefully you were able to pick out that 100 represented the perimeter. And when I think about perimeter, I know it's 2 times the length plus 2 times the width. So when I look at this, the perimeter, 100, 80 represents 2 times the length, and 2w represents 2 times the width. So what does the w represent? The w represents the length of one width. So when you look at this drawing, I have 2 w's. So the w represents one width. The 2 represents that I have 2 widths. And then the 80 is going to be the distance of 2 lengths because this is 2 lengths and it gives me just 80 because I know the length is 40. So the 100 is the perimeter, the 80 is the total distance of 2 lengths, and the 2 represents that there are 2 width sides, and the w represents the length of one width. All right, so we can explain the values of the equation and what they represent in the context of a situation. Go ahead and pause the video and have an interaction in your notes. All right, so we're going to go back to that YMCA package. One of our objectives is we need to be able to identify if something can or cannot be a solution and what it would mean in the context. So when I think about this right here, I'm paying $35 plus $2 a class, and this is my cost. X is my number of classes. So within the context of the problem, can I have f of negative 5? Meaning, could I put negative 5 in here and it makes sense? So when I go back to what x represents the number of classes. So if x represents the number of classes, can I have negative 5 classes? Well, no. Okay, so what about f of 0? can I put 0 in for x? So if x is number of classes, in theory, could I take 0 classes? Yes. And then f of 5. So can I have 5 classes? Absolutely. So when I'm thinking about what x represents, I need to understand, can I have negative values as input? Can I have 0? And can I have positive values? Do they make sense in the context of the problem? All right, that was our last objective, is to be able to explain the constraints on a solution within the context of the scenario. All right, go ahead and have your final interaction, and we will be done.